morning, welcome back to the course Engineering Metrology. In this module, we are discussing the statistics in metrology. So, in this lecture, I will take what is data and what are the scales of measurement. These are not the scales, the physical scales, these are actually statistical scales or the scales how the data is organized. Okay. So, the contents would move like this. I will try to compare the data and information. These two words are used interchangeably and multiple times you might have heard, okay, we have this information, we have this data, but there is a difference between these two words. I will just discuss that, and then we will discuss about the types of data, qualitative versus quantitative data. Then we will discuss the scales of measurement. Then I will discuss about discrete and continuous data and how these are used in probability distributions. Before that, we will just look into what is probability. You people already know what is probability, but how the frequency or probability distributions are designed and why what can we extract from that, what inference can be taken out of the fitting the data, the specific data that we have obtained from measurements, from the physical measurements, how can we fit that into the specific distribution, or which distribution has which kind of applications. These things we will see. So, first of all, let us see what is data. Data is the set of values, those are collected by some measurement, by some observation, or maybe from the secondary information. As I have discussed that the two kinds of data, primary data and secondary data. Primary data is that we collect from the basic source, from the actually we do the experiments and then we find the value, we observe the value, then we record it. That is primary data. Whatever in laboratory demonstration, whatever we have been doing, that was primary data. Secondary data is the data that is already recorded. For instance, the standards, the specimen standards, those are there, those are secondary data. So, data is the, okay, I will put the definition. Data is the collection of values. So, this has come from the Greek word datum. Datum means, when I use the word datum, it means the single value. If I say height of this stylus, okay, the height of this stylus is about 15 to 17, I will put it 17 centimeters, okay. This is 17 centimeter, this is one value, and if I take multiple styluses and take the height of that, that might become data when I manufacture that, okay. So, this is one datum, okay. This is collection of values, and if I keep on collecting the values, if for instance, if I have the values like 17 centimeter, 17.1 centimeter, 16.9 centimeter, 17 centimeter, this is just data. And if I talk about the data broadly, like even out of the scope of our engineering metrology, data is a very wide or broad term that is used for the numbers or maybe actually the two types of data, qualitative and quantitative data. So, generally data is it may be numbers or it may be some attributes, okay. So, there are also terms like big data, like in industry there is a lot of data regarding like in the whole life cycle or in the whole, I would say, supply chain cycle of the industry, okay, from the very raw material to the finished good. We do in metrology and metrological applications are always there, okay. When we have to get the raw material, we check that whether the raw material that we have received, okay, is that acceptable or not. We have to do some measurements, we have to do some calculations sometime, okay. So, at each point data is collected. So, big data is whole supply chain, who is the vendor, what are the prices, what are the market trends, and what would customer like to pay. all the, see, data is available in all the kinds of spheres of the manufacturing, but it is not in a structured way. It is unstructured data. So, data is generally unstructured. Okay. So, in scientific research, data is collected by a huge range of organizations and institutions, and that is used to extract some information. Now, what is information? Information is when we try to extract something from the data, and like some evaluation, some calculations are done, and the data is a little structured or organized. Okay. For instance, this is the data, all these points 1, 2, 3, 4 and 5. This is data, the heights. If I take mean value, mean mu, let me say the mean would be about 17 centimeter only. This is information. Mean value, median, we have the million, okay, the mean value of the n number of components, mean of the height of the n number of components is this, is 17 centimeter. Okay. This is information. Information is extracted from the data by calculations or by analysis. Okay. There is another term that I will not discuss more, that is the knowledge. Knowledge is actually personal. When we have a lot of information, like if I know, the generally used word is, do you have the knowledge how to operate this instrument? It is knowledge actually, it is not the information. I have the information, okay, the procedure to use this. The knowledge is the connection of knowledge is actually gathered all in your brain. When I hold the instrument, I have the knowledge of all the things, how to hold that, what to hold in my left hand, how to use my right hand. Right hand can be used to work in more precise way, okay, for precision movements, and how to hold it, where should I, how should the instrument look, how should I read that. This, all these things, when those are connected, the final application from the information that we can use finally is actually knowledge. Okay. Knowledge is personal. So, the instructors, the practitioners, the lecturers, okay, the management people, they have different kind of knowledge sets. So, that interconnection of their knowledge spheres or fields make them expert in something. Okay. So, this is data and information. This is a general overview, because these two terms were being used interchangeably multiple times, and just to make it a little clearer, I am trying to detail it a little. So, gathering data can be accomplished through a primary source or a secondary source. Data analysis methodologies can vary depending upon different kinds of availability, environment, and maybe data triangulation, data percolation are a few methods, and we need not to discuss all this. I will move to the next part, qualitative versus quantitative data. The terms in itself tells something about that. Qualitative data is the one which just tells about the quality, it is about the attributes. Okay. I can say good or bad. Okay. The quality of the pen is good or bad. Okay. Acceptable or non-acceptable. If I am using the two terms, good, bad, acceptable, not acceptable, yes, no, true, false, whatever that is. Okay. So, these terms, this kind of data is dichotomous data. I will discuss that as well. So, qualitative terms, qualitative is when we use attributes. Okay, I will just differentiate it, qualitative and quantitative. Okay, when I discuss about the height of some measurement, okay, some measurement height of that or some length, I can say this is long, this is small, this is medium, 3 categories. Okay, these attributes can be long, medium and small. Okay, it can also be if I use 2 terms, long and small. Okay, medium is in between. So anything like okay, color can be there. Okay, color dark or light color, dark or pale, dark or light. Okay, then even if we say color is yellow, blue, orange, this is also a kind of qualitative data. But if I give the values, for instance, I am talking about the pencil, let me say the height of the pencil, if it is 17 centimeter, it is long, then 10 centimeter is medium, 5 centimeter is small. So these, if I measure the exact heights, these are actually numbers. These are actually numbers and these are measured. Okay, attributes are not measured, these are observed. Okay, 17, 10, 5, it could be 10, 11, 12, 13, 14, 12.5, 13.5, any number could come. Okay, the thing is that I am trying to explain is that we can even put the quantitative data into bins to put the have the qualitative information. Okay, I can see, I can divide it into multiple parts here. Okay, I can say from 15 and above it is long. Okay, long, that is 15, and above 8 it is medium, 8 centimeter, and less than 8 is small. Okay, so actually medium is between 15 and 8, more than medium is long, less than 8 is small. So I have put the quantitative data into bin as well. So the role of or the research that could be done in qualitative data is just exploration. Okay, this is big, small, these are the things available, the quantity is high, low, the temperature is cold, cool or hot. I can just explore something, but we cannot apply very powerful statistical tools here. However, there are statistical tools available for the qualitative data as well, because in certain measurements like in go no-go gauges, are actually also derived from the quantitative data only, because we have the value for the go and the no-go ends. Okay, but sometimes the quantitative data is not possible to attain. Okay, but then qualitative data is also to be worked on. We can see the goodness of fit using chi-square test that we will discuss. But the research is generally exploratory, exploration. Okay, here we can give some inference or some conclusion. We can give some value. Okay, this is the control limit, above this value we cannot accept, below this value we cannot accept. So we can design something based on the quantitative data. So quantitative data is always preferable if possible, depending upon the cost, the time. If it is possible, if the cost of the getting data, primary data is too high, we can even rely upon the qualitative data if that is acceptable, if that can be worked on. If the time to get the data is too long, then also we sometimes have to rely upon the qualitative data. For instance, we think about the data for the global warming. Okay, if I think about the temperature in last 100 years, okay, the temperature of our globe for last 100 years at different points in our in different countries, that is the quantitative data. Okay, the qualitative information or the information that can be extracted is the temperature rise can be the global phenomena, global temperature rise is there, global warming is there. This is one thing. Okay. The quantitative data is exact temperature. Exploration in the qualitative way, I would say, it can say is just hot, cold. If I talk about the temperature of my city, Kanpur here, the temperature is hot, cold. What exactly is the temperature? If I have to do some measurements using an instrument which is temperature sensitive, can I do it in the open environment or not? For that I need to know the exact temperature of the environment. Okay. So for solar panels also, like what amount of heat is hitting the solar panel for the PV panels of the solar plant. So that also that can be quantified as well. So these are a few examples. Okay. So next point I can say here that this is generally non-statistical. Generally, this can be used in statistics. As I just said, a very few tools are available, or not, a few tools not available actually could be applied to get some information from the qualitative data. But yes, if the data is quantitative, we can apply statistics to get different kinds of information, and we can also conclude something. Okay. The sample here in the qualitative data is a non-representative. In the quantitative data, the sample is representative. So this qualitative data is actually used for the initial understanding. Initial understanding, and from the initial understanding, if we need, okay, the data has to be quantified, then we can do the further experiments to have the detailed information, or have the detailed understanding or the further course of action. Next is the scales of measurement. Scales of measurement are very important. When I talk about data, qualitative or quantitative, the qualitative data is also known as, sometimes it is categorical data, actually, yeah, categorical data, and this is numeric data. This is actually already mentioned in the point 1 here. So when the data is categorical or qualitative, it can be of two forms. Actually, these are stages: nominal or ordinal. Nominal data is nothing but the word is name here. The word is nominal. It comes from the word NOM. Okay, it can be, we can just remember it is just the name. Okay, like I say, I have 5 samples. I just number the samples: sample number 1, sample number 2, number 3, number 4, number 5. I have just put the names. What do these names represent? It just helps me to recognize which is sample number 4. But is it possible, can I say that sample number 5 is better than sample number 4 without any other information? Can I say that sample number 5 is better than sample number 1, or can I draw any this kind of information from this? No. So this is just the name. Example here, maybe I can say operator, now operator 1, operator 2, operator 3. This is actually the operator who is doing the measurements. Okay. For instance, if my factory is running for the whole day round for 24 hours, and the workers who are working on one machine, and 8 hours shift is there, so 3 workers will be working if the machine is working for 24 hours completely. So I have to name the 3 operators: operator 1, operator 2, operator 3. Okay. If I see that there is some trend, like the quality that is operator 1 is giving is a little lesser than what the operator 2 is giving, okay, and the operator 3 lies between operator 1 and operator 2, that can be ordered as well. That kind of data is known as ordinal data. Now, if I say operator 1's, this is actually the name, operator 1's, I am telling, operator 1's skill is better than operator 2's skill, okay, operator 3's skill as I said, and it is better than operator 2's skill in working on a specific machine. Okay. Now, I have put operator 1's. Operator 1 is a noun here, operator 1, okay, like Amandeep's, Ram Kumar's, okay, some you can use some name, okay, Siddiqi's, okay, Shubham's, we can use some name, this person's skill. So, operator 1's skill level can be attributed, or this skill level can be further, okay, we can quantify that skill level, can be put in on a scale, maybe Richter scale, 1 to 5 scale. We have certain ways to do that as well, but I am just talking about that. Operator 1, operator 2, operator 3 were just names. Now, this is the order for this skill. This kind of data is known as ordinal data. Okay. Like I said before, in the qualitative data as well, quantitative data can also be ordinal. In ordinal data, for qualitative example, like I say, okay, long, medium, small. This is order. Long is greater than medium, medium is greater than smaller. Okay. And in quantitative data, we just have the information 17 centimeter is greater than 10 centimeter, which is greater than 5 centimeter. So, this is the kind of scales, nominal scale, ordinal scale. Ordinal scales. Now, in nominal scale, we cannot compare, we cannot say that operator 2 is better than operator 1, or whatever that is, okay. But in ordinal scale, yes, we know operator 1, if I rate the skill from 1 to 10, let me say his skill level is 8 out of 10, this operator's skill level is 5 out of 10, and this is 2 out of 10. So, there is an order associated with it. So, this is ordinal scale. We will use this scale in our numerical problem as well. Where is the ordinal scale working here? And next kind of scale are the metric scales for the quantitative data. Okay. Now, next I have kind of scale is interval scale, and next to that the final kind of scale is the ratio scale. These two kind of scales are generally quantitative. Okay. So, the difference between the interval and ratio scale is that, so actually there is order associated with it. This is the first kind, this is the second kind, this is the third, this is the fourth. As we are moving from the first to fourth, the extent of information is increasing. We can more apply the statistical tools, we can use it in a better way to draw some inference out of this. So, interval scale is a quantitative scale where the order, whatever we just had the order, operator 1, operator 2, operator 3. Okay. Now, if I have the specific value for that, for instance, it's 8, 5, 2 was the value. This is an interval scale. So, it is the classification or order or distance, but it has no origin. It is important, it has no origin. Here we have from the word, from the letter O, you can say it has a specific origin. The example for the interval scale could be temperature. Temperature, we call it temperature in degrees, in degree Fahrenheit, in degree centigrades, okay, temperature in degrees. So, can I say that if the temperature is 25 degree for one body and 20 degree for another body, if I put them together, can I say the total temperature is 45 degree? No. There is a big model, thermal model associated with it. If there are two bodies, okay, what is the material of these bodies? what is the surface, total surface area of contact, what is the thermal conductivity of two bodies. So, what time would it take for the temperature to come to the same value at both these ends and at its center, depending on the environment temperature. This is a big model associated with that. We can do that, okay. But in general, I will say the temperatures are not directly additional. We cannot divide 100 degrees by 25 degrees directly, okay. But ratio scale is one when we have the definite 0. We did not have the definite 0 for the temperature. We have the definite 0 in the ratio scale. The example can be the multiple examples here. The example can be any lengths or heights, okay, heights in millimeters. So, or heights, age, then weight, okay. These all are in ratio scale. We can say, okay, if I having 5 kilos of apples, if I divide it into 5 parts, each one would get 1 kilo of apples, because this is a ratio scale. I can even say if there is a length, if there is a stick of 1 meter, I need 2 sticks or 3 sticks of 33 centimeters, or let me say at least 4 sticks of 25 centimeters. I can cut these into 4 parts. In other way, 100 centimeters by 25 centimeters is 4. It is directly, the ratio is there, okay. That is why it is known as ratio scale. But we cannot say if the temperature is 25 degree, okay, I will divide it into 2 parts, 12.5 degree to 1, 12.5 degree to 2, this is senseless, okay. So, that was interval scale, this is ratio scale. Whatever measurement, the linear measurements we are doing are mostly in ratio scale. So, where do we apply these? We will discuss about the probability distributions. In probability distributions, we will use interval and ratio scales mostly. I will just use the nominal and ordinal scales to discuss about a few statistical tests, but most of the times we will work on the numeric data. So, this is numeric data, as I have said, quantitative data is numeric. Okay. About scales we can talk for multiple hours. You can ask the questions in queries, and I will try my best to cater all of them in the best possible way, but we have to move further. For after this information on the kinds of scales, I like to discuss further the 2 kinds of data which are discrete and continuous data. So, about these 4 kinds of scales, what kind of statistical parameters can we use? The order of values is known in ordinal, interval and ratio data. In nominal data we do not have any order, but we can have frequency distribution for all the 4 kinds of data. I can put here the frequency distribution. This can be for NOIR for all these, okay. Number 2, what kind of the statistic can we use here? The mode, for nominal data, mode is the maximum value, okay. For nominal data we can use mode, but not median, because we cannot compare them. We can have mode here, okay. If I say MO mode, mode is possible here, mode is possible here, here and here. So, if I say, okay, I will put it here, mode, median, mean. So, mode is possible in all these. Median is the middle value. We cannot have median in the nominal data, but in ordinal, interval and the ratio scales we can have the middle value. Like in order also we can have the middle value, but we cannot sum the order up and take an average. That is not possible. Mean is not possible. So, we can have median. I will put median here. Before median I will put MD, median, and mean can be calculated only in the numeric data. So, we can multiply and divide. In case of ratio scale it has a true 0, but yes, we can add and subtract sometimes in the interval data as well, but multiply is not at all possible. So, this was about the scales of measurements. So, next I like to take a little break here. I'll move to the next part of the lecture where I'll discuss about discrete and continuous data, and then we'll move to the probability distributions. I'll not like to lengthen this lecture a lot. So let us meet in the next part of the lecture. Thank you.